Sensor inputs. There are three mandatory sensor inputs to ECDAS, as stated in IMO MSC 23282. 1. ECDAS should be connected to systems providing continuous position fixing capability GNSS. 2. ECDAS should be connected to the ship's gyro compass. For ships not fitted with a gyro compass, ECDAS should be connected to a marine transmitting heading device. 3. ECDAS should be connected to the speed and distance measuring device log. Global Navigation Satellite System GNSS is a general term describing any satellite constellation that provides positioning, navigation, and timing PNT services on a global or regional basis. While GPS is the most prevalent GNSS, other nations are fielding or have fielded their own systems to provide complementary, independent PNT capability. A gyrocompass is a form of gyroscope used widely on ships employing an electrically powered, fast-spinning gyroscope wheel and frictional forces among other factors utilizing the basic physical laws, influences of gravity, and the Earth's rotation, to find the true north. The speed log is a device used to measure the speed, and also the number of nautical miles the vessel has traveled through the water in a given time. Apart from the three mandatory inputs prescribed by the IMO, many other sensors may be interfaced. However, ECDAS should not degrade the performance of any equipment providing sensor inputs, nor should the connection of optional equipment degrade the performance of ECDAS to below the IMO MSC 232 standard. ECDAS may also be used to provide ENC information to external equipment, such as radar. To provide redundancy of sensors, a typical ECDAS configuration may be as follows: GPS 1, GPS 2, Gyro 1, Gyro 2, Speed Log, Distance Log, AIS, Echo Sounder, Anemometer, Navtex, ARPA 1, ARPA 2. The ECDAS operator should be aware of how to select a backup or manual input available on their system. All sensor inputs to ECDAS must be properly configured and calibrated during ECDAS installation. Failure to do so will result in inherent errors in the system. The ECDAS operator should regularly check the accuracy of sensors using all available means, such as the methods listed below, to ascertain any errors. If an error is discovered, the ECDAS operator must investigate it and take appropriate action. GNSS cross-check accuracy by regularly conducting operator fixes using visual and other means. Gyro. Maintain awareness of gyro errors, repeater errors, availability of backup heading information. Log. Check accuracy by using the measured mile method or similar technique. Echo Sounder. Check accuracy using a lead line or reference depth method. Radar. Check accuracy by regularly conducting index error checks and operator fixes. RIO can be used to check the radar. ECDAS operator must be familiar with the use of the ECDAS, considering that the operational techniques and methods of cross-checking will vary, depending on the area of navigation. Pilotage in confined waters. During pilotage in confined waters navigation, the system is to be used in conjunction with radar information overlay, if available, to confirm GNSS positions. During restricted visibility, the ECDAS operator should use ECDAS together with a dedicated radar display. Coastal navigation. While operating in coastal waters, the ECDAS operator should monitor the radar coastline layer on the chart using the RIO where practical, and cross-check the position of the ship using visual or radar means to prove the accuracy of GNSS. Ocean navigation. The primary source of positional information will be GNSS. Check periodically using celestial means when possible. Glossary for electronic charts to be used with ECDAS. ENC. Electronic Navigational Chart. Official vector chart containing a database of individual geo-referenced objects taken from hydrographic offices' documentations and record, inclusive of paper charts. It is issued for use with ECDAS on the authority of National Hydrographic Offices. RNC, Raster Navigational Chart, digital copies of paper charts complying with iOS 61 product specifications for Raster Navigational Chart authorized by National Hydrographic Offices. Some flag states allow RNC to be used for backup purposes in the areas not covered by ENC. SENC, System Electronic Navigational Chart, ENC dataset converted into the system language of the ECDAS, which facilitates rapid chart drawing of the ENC data on the ECDAS. S57. ENC chart data format defined by IHO transfer standard for digital hydrographic data. S52. IHO defines symbols and colors for chart presentation. S63. IHO data protection scheme for ENC against unauthorized amendment or illegal copying. Other global navigation satellite systems: GNSS, Beidou BDS of China, GLONASS of Russia, QZSS of Japan, Galileo of Europe, ERNS-NAVIC of India,